if you've been listening to me, kind of doing what I've been showing you to do, this lesson is no big deal. Sure, there's going to be some tricky problems, but you won't have fundamentally things that might mess you up, okay? If you listen to me when I told you logs and exponents undo each other, you won't make mistakes with these questions on this page. Okay? Because change this to 10. Some of you out there have resisted Mr. Messner's idea of, we use a log to solve an equation. X should not change size. Some of you have resisted that and have written answers with X popping on the other side. Who amongst you has told me, I just get it. This is how I get it. It's fine. Well, put that inequality right there, and you're wrong. This is wrong. This is wrong. So we're going to talk about why it's wrong next, after lunch. Okay. Change this to 5. So, guys, I've been trying to convince you to think of logs and exponents as inverses of each other used to help solve equations, because the last lesson of this unit is solving equations. If you roll things around, because this is how you learned it last, and your x goes to this side, and you have a log base 2 of 10 on that side, if this was an equation, sure, you're still right. But once it's an inequality, this would be wrong. This is wrong. I've been trying to tell you, because it'll help you for all situations in this lesson, and really just in general for your understanding of logs and exponents, that you can take a log to undo an exponent. And here, log base 2 of 2 to the x is just x, and x is greater than the log base 2 of 10, and this is correct. If I had things in the opposite way, I'd be wrong. For example, this guy over here, let's just erase this guy, replace it with this guy. Log base 2 of x is greater than 5. I'll move it over. Log base 2 of x is greater than 5, or less than 5, I don't care. Okay. If you are one of those students who kind of my algebra 2 teacher taught me that we got x and 2 to the 5th, and it's great. If this was an equation, you're correct. But it's not an equation, it's an inequality, and it just goes to show you, for this lesson, and really just for the entire unit, if you just thought of it as a way to undo, exponents will undo logs. You'll make sure you get the right answer. 2 to the log base 2 of x is just x. X is greater than 2 to the 5th. 2, 4, 8, 16, 32. Not 10. No, it's not. It's 2 to the 5th, not 5 squared. And that's another reason. If you're trying to memorize a process, you might memorize it the wrong way. Okay? And all of a sudden, you're telling me it's 5 squared. And all of a sudden, you are messing up with exponent properties and log properties, and you're telling me that, x squared cubed is x to the 8th. And it's no, stop doing that. Just we've got to just keep it simple. Try to keep it simple as much as possible in this class, because things get complicated. Okay? So, when we solve equations with logs or equations with exponents, put in 2 to the x plus 2 equals 7. This is an equation we already solved on the right. I'm just going to repeat it here. To undo a log, we use an exponent to undo an exponent, we use a log. So if I have this equation right here, I would get rid of the log base e using an e to the power. I have x squared minus 24 equals e to the 0, which is 1. And I know that, and I'm writing it down. I can isolate x by moving the 24 over and then square rooting, or I can move the 1 over and factor. It doesn't matter. There's multiple ways to do this. I get answers x equals negative 5 and 5. We'll come back to this one in a second. Over here, I could take the log base 2 of both sides. I would do this. There's other ways to do this. We could have used exponent properties to rewrite things. Like there's other ways to do exponent problems, but eventually you will take the log base 2 of both sides to undo a 2 to the power. I'd get x plus 2 equals log base 2 of 7. I get x equals log base 2 of 7 minus 2. This is one way to do it. Let's say I don't want that form. Well, I could go back and before taking the log base 2 of both sides, use my exponent properties to write this as 2 to the x times 2 squared. I don't like using 2 squared, but it did show up there. Giving me 2 to the x times 4 equals 7. Divide by 4, isolate the 2 to the x, and now use a log base 2. You get the same exact answer both ways, but like the key. Use an exponent to undo a log. Use a log to undo an exponent, okay? And if we thought about that from the beginning, then this is not new. But for some of us, it is new because you've been rolling things around. If I log 2 from the start, I'd get x plus 2 equals log 2 of 7. And I would get the answer log 2 of 7 minus 2, which is equivalent to that. Okay? Because negative 2 is the same as, well, 2 is the same as log base 2 of 4 minus log base 2 of 4 from log base 2 of 7 gives you that 7 fourths. Now, heads up though. One of these two equations I got to be careful with. Which one of these two equations do you think you have to be more careful with? This one with the log that started with the log, or this one that started with the exponent? Tell your neighbors, what do you think? Yo. The answer is the one on the left. The answer is the one on the left. Why? Well, it's like 2 to the power can only equal something that's positive. Okay? That's set up. That's good. As long as I'm doing everything normally, I'm just going to get my answer and not going to worry about it because there is some power of 2 that will give me 7. It's going to be a crazy decimal, but that's fine. The equation on the left I have to worry about. Why? You can't plug in a negative inside a logarithm. Okay? You have to remember that if you have the log of any base of x, whatever is inside that log, caballero, has to be positive. So, heads up team, when we have equations that start out with logarithms, we're going to have to make sure our answers can work or will be defined. And sometimes, after getting rid of the log, we will get two answers. One, or even both of them, might not actually work. If I plug in 5, okay, I get the log of 1, which is 0, that works. If I plug in negative 5, okay, I get the log of 1, that's fine, that equals 0. These are fine. But you'll see with the other equations that we're going to solve, it won't always be fine. For example, here is a log equation that we'd like to solve. Now pause. Maybe you've done a first step. Maybe you haven't. Here's what I need you to worry about. And here's why we learned last lesson. Why did we learn last lesson? We have these log properties that we could either condense or expand logarithms for this very reason. Because many of you might think, oh, Mr. Messer told me 2 to a power both sides, and then you get x plus x minus 1 equals 2. Wrong. Wrong. You cannot take 2 to the power of both sides and just both of these log 2's disappear. If you tried to do that, I like the idea, but you actually can think of these as being in an exponent. You can rewrite these as in terms of an exponent. What you would end up doing is discovering the log property yourself, but we already know the log property, which is that if you are adding logs, you can multiply the inside, getting this. This is why we learned log properties. For all of your log equations, and these are why we're going to spend more time on log equations, but we will eventually get back to tough exponent equations. For all of your log equations, heads up, you got to pay attention to the domain. You got to figure out what are the x's that we could get. And it's easy if you get numerical answers going back and plugging them in. And 2, don't forget about your log props. Okay? So I use my log properties to isolate a log base 2. I use 2 to the power. I get x squared minus x equals 2. I now can subtract 2 and have a quadratic that we have to solve. Why on your homework did you have all of those questions where you had to distribute for these questions that we're about to do now? You didn't see them on your quiz, but you had them on your homework because it was getting you ready for these things. Okay? Tell me more specifically what you're thinking about here. Like if you would square, would it get rid of the whole left side usually from left to box? So give me the normal equation, like x plus x minus 1 equals 1. Yeah, it was like x squared plus x squared, blah, 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 and then you square root of, would it get rid of the x squared? So, I hear you. I feel you. X squared plus 4x squared. Let's say I had that. Would you get rid of both of those powers? Yeah, no. So here's the rule. Addition hates simplification. Addition is simplification's arch enemy. This can't be simplified. You can turn this into 5x squared, and then you have root 5 times plus or minus x, okay? So no, you can't turn this into x plus 2x, which is why you can't take 2 to the power of both sides and just say it's x plus x minus 1, okay? Because of the plus. That's a simple thing to remember, okay? So we do isolate the log. We do use log properties. We do get a quadratic that we can solve. We do get 2 solutions, x equals -1 and 2. But are these the solutions we're looking for? Tell your neighbors. No. Which one is bad? -1. The -1's bad because we're not allowed to plug in a negative into a log. This is called an extraneous solution. What does that mean? It's a fake out. It's like, hey, it's something we think solves the equation, but it's the fact that we're using powers makes it a little bit more complicated than that. Okay, we are going to stick to more log equations first. Start over, that was great. What did you just say? Yes, I feel you. But, Schreier, go back into the original equation. Go back into the original equation, the first equation before we use the log property and before we squared both sides. Can you plug in -1? Okay, that's what we're doing. Okay, moving on. Remembering, guys, if it's inequality, don't let things go to other sides on you, or you're wrong. Don't let things go to wrong sides of you, or you're wrong. Not going to spend much time, but this is just confirming. Team, don't let things flip-flop on you. Let's just stick to solving equations by using the inverse, by like doing what's going to undo. Okay? Cool. Moving on. Ready? I don't like these equations. I like this guy. This guy's good. We're going to stick to a couple more logs first, and then we'll move to exponents. So don't do the one on the right, just do the one on the left. We've already solved a lot of like trickier exponent questions in past lessons, like the lesson 3 when we were introduced to the use of a logarithm. We solved some exponent equations. So we are going to use like our log properties that we're learning and we learned last class to solve some log equations. So we got this guy on the left. Let's go to this guy on the left. Biggest mistake made is to think you can take 10 to the power of everything right off the bat. A lot of people might think, oh, can't I just 10 to the power, 10 to the power, 10 to the power? The answer is no. Because of this plus, you can't do this. A lot of people think, oh, it's x plus 2 plus x plus 5 equals 4. It's not. It is not. Like, oh, can't we just like divide by log? No, you can't just divide by log. You might think you can, but it's not something to be divided, first of all. It's a function. The only way it can be undone is if you have 1. So this is why we practice on our homework all of those questions where you combined your binomials. So we had 1 logarithm on the left side. Now we have 1 logarithm on the left side. I don't really care about the right side. The fact that it has a logarithm, great. I don't care. It could have a number. I would do the same thing no matter what. I would take 10 to the power of both sides. Many of you might think, oh, it's going to go away. It's like, yes, it does, but it's because I'm doing this operation that it does. Yes, but I'll show you. Let me finish. That's a lot. It'd be a lot tougher. Okay, so we get x squared plus 7x plus 10 equals 4. I subtract 4. X squared plus 7x plus 6 equals 0. X plus 6, x plus 1 equals 0. X equals -6. No, it doesn't. X equals -1. Yeah, that works. What you'll find is like, you got to remember your log properties. Don't think that the equations are easier than they really are. Do you have any questions? Okay. There was one question was, what if we subtracted log 4 to start? If you subtracted log 4, you could write this as log x plus 2 times x plus 5 over 4. But you subtracted the log 4, that equals 0, right? When you take 10 to the power, yes, the left, the left side, the log will go away. The right side becomes 1. Shwari, would you agree with me that 10 to the 0 is 1? Yeah. Okay. What would be the next step that you would do?
Multiply 1 and 4.
Yes, I would multiply both sides by 4. What do we end up having? The exact same thing as what we had. If we just combine these and then take 10 to the power, we'd have that 4 on that side. So like what you did is fine, but it's just like not helpful. Does that sound good?
I thought this was easier.
No way. Stop it right now. You immediately stop right now. Stop it right now. If you kept, Shwari, log 4 on this side, those logs go away, and you get this. This is x squared plus 7x plus 10 equals 4. Subtract the 4. Okay, moving on. We're going to go back to that one on the right. Do this one really quickly. On the next page. Leave plenty of space. We are adding more questions to prepare you for the quiz. Yeah. Okay, so these are the questions, kind of like step 1. These are the trickier log questions where we have to use log properties and we have to pay attention to the domain. Ready, set, go. Ready, set, go. We're on the next page, Wood. Thanks for sticking with me.
Yeah, no problem.
Yep. It is. But you messed up on your... No, never mind, you're good. It is. 9 and 8. 9 and 8. Okay, good man, Keith. How are these bros doing over here? Yo, ho, you're not doing what you should be doing. You're not doing what you should be doing. You're like, things are disappearing. You're not paying attention to what you have. And those of you, in my opinion, who, on your quizzes, have just been writing the answers are just not going to get the right answers because you're not understanding the delicate nature of what you have. This is perfect, Mike. You're doing everything that I want you to do. Those of you who are skipping steps. Because -6 plus 2 is -4. I can't have the log of -4. But if I plug in -1, they're all work. Good. 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 Yeah, keep going. You got it. You got. Oh no! 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 That's why I like to change subtraction and to add the opposite. No! So I like to change subtraction and to add the opposite. No. Perfect. You messed up on 7 times 8.
How about that?
Good. Great. Yeah. Good. So, there's only a few of you out there who's like, oh, this is easier than this really is. I don't have to show work. And those of you out there just did x squared minus x minus 56 equals 2. You then subtracted 2, and you got minus 58, and you were wrong.
Where
okay?
was the log?
Exactly. Where was the log? You know, where is all of the little pieces? Where's all the details?
Why are you?
Because it's exciting. I like to be adamant. Yes, I like to be adamant in what I'm doing. to convince you to pay attention. If I'm not excited, Linder, why would you be? You know?
Exactly.
Exactly.
Why should I be excited about that?
Because your teacher's excited. That's why.
Well, I like
And
it.
because I see you doing the right thing, and you know what? I'm excited. I'm excited that you're actually paying attention and you're listening and you're doing what you should be doing. Even though you like to pretend that you don't care and you're sleeping all the time, I know that's just for show, and you do care. So I appreciate it, Linda. I appreciate that you really care, deep down. Yeah. Okay. All right. So we use the log property. The log is still there. It didn't disappear. We took 4 to the power of both sides, and then it goes away. And then I factor. And then I get my solutions. It's not that it's negative, which is why it's an extraneous. It's when I plug it into the original, I get the log of a negative or the log of 0. And that's why I don't like this one. Okay? Great. Yep. Ready, set. Ready, set. Ready, set. Let's make them harder. This exponential equation on the right. We're going to do that one right now. Ready, set, go. Yeah, it's supposed to be hard. Let's see if you can do it. Sorry. I don't mind. Yeah, no, it's okay. Like, if you swear in this class and it's out of like a mathematical like conundrum, I'm okay. I had somebody in my calculus class. In my calculus class, they were like throwing their paper in somebody's face and like, look at the effing graph. It's over. And I was just like, yep, I'm okay with that. That's fine. You know? Well, figure it out. That's what I'm going to say here. All right? Okay. Okay. Ready? Ready? So many of you were good with the condensing the logs, right? Many of you were thinking I should natural log both sides. But many of you either thought that this right side was easier than it really is, and you wrote 10x. That's wrong. Many of you are correct that the left side's 6x. What's the natural log of e to the 6x? Okay, great. So we remember that natural logs and e to powers undo, and you skip the powers. So you need to remember log properties to sometimes expand, because this is not 10x. This is the natural log of 10 plus the natural log of e to the x. If you did that, nice instinct. If you didn't do that, that's okay. We forgot that there's also expansion, not just contraction. Okay. Well, finish it off for me, please. Finish it off for me, please. No, yeah, you don't have anything. I know. No, you don't. No, come on. We're doing the one on the right. Yeah, because you weren't paying attention, Nancy. That's very easy. I love it when people are like, oh, yeah, because you're talking to Woods the entire time. Can you finish this? What's the natural log of e to the x? Nancy, are you kidding me? You're going to like listen to Iyer and not know what the natural log of e to the x is? That's it. Oh! That's it. Great. We get 6x equals ln 10 plus x. No.
Did you consider the multiplier? This is weird. Are you multiplying by what test? Jesus. Multiplying by what test? Are you, hello everybody, by what test?
I know what you were thinking, but tell me why it's wrong. What? Because we can't do that again. Okay. Now, many of you don't see that natural log of e to the x is just x. Many of you don't think to subtract the x, but that's a good idea. Many of you divide by 5 and tell me that the natural log of 10 divided by the 5 is the natural log of 2, but that's not right. We know that dividing by 5 is the same as multiplying by 1/5. We know that the answer is really the natural log of 10 to the 1/5. If you wanted to put that, that's great. We're ready for that. We're ready for that. Now, there is another way to do this, and I show it on the homework video, but I don't want to show it to you because this is a good technique. Whenever you have exponents on both sides, taking the natural log, even if it's not a good base, even if it doesn't work with the base, taking the natural log can really be used for your advantage. So let's do our next hardest one, which is on the blank piece of paper, not in your notes, but you're going to add it. Yes, you have two more questions, and these are the two hardest questions. So if things are going well so far, well, some people are like, when is this going to get harder? Here it is. Okay. So even when you don't think it's a nice one to work with, it can be used. The log of any base can be used to help solve exponential equations. We looked at the change of base. We looked at how, hey, any log base equates to any other log base just with some vertical dilation. So 4 to the x plus 2 equaling 5 to the x plus 1, the first thing we're going to do is take the natural log of both sides. No, it's not. The answer is a very complicated decimal. I'm going to take the natural log of both sides. You could take the log base 4 of both sides, fine, but I'm just saying I'm going to want my answer in this form. Mostly, it's just easier to write ln over and over and over again because we're going to have to do it. Okay? This can be done. All right. Now, you guys, with your log equations, condense. But then on the last equation, you use the expansion property. You took the log 10 times e to the x, and you expanded it to be log 10 plus log e to the x. What type of expansion properties can you do here where you have natural log of 4 to the x plus 2 and the natural log of 5 to the x plus 1? Tell your neighbors. What's an expansion property that maybe is? No. No. Now, yes, Schreiber, you could do that. And I'll show you a different way to do it, but it ends up being like just the same in terms of its complicatedness. We can take the power and bring it down.
Oh.
Okay. We have x plus 2 times the natural log of 4 equals x plus 1 times the natural log of 5. Now, this is not what we're doing, but I'm using this as an example to show you why we will do what we're doing. If I gave you the equation x plus 2 times 4, again, I'm not doing that, but I'm just using this as an example, times x equals x plus 1 times 5. If I gave you this equation right here, what would you do to solve this equation? What would be your first step? Tell your neighbor. If I have x plus 2 times 4 equals x plus 1 times 5, what would you do? I would distribute. Okay, well, we're going to distribute this. Now, you're going to be like, how do you distribute it? Well, you just multiply log 4 by x and log 4 by 2. I'm about to disband the Woods table. So, no, we don't want to do that. We'll end up going back to kind of where we were, just maybe even more complicated. We want to kind of like, we want to get x, all right? X is down. We're in a good spot where x is. Feel me, Ire, I got you. If you find a different way to do this problem, you let me know, okay? Yeah, no. Sorry, bud. You can't do that because of the plus. You do e to the power of both sides. You're going to have to do e to the entire side, not just that little bit. Okay. Now, let's continue on with this example here. Let's continue on with this example here. What would you do to solve this equation right here? You would like combine your x's, right? And you combine your numbers. We are going to do that with one quick little pit stop. What is, okay, good. Okay, so good thing here, right there. Ready? Watch this. Let's start by combining the x's. I'm going to subtract x ln 5. Now, this is very confusing to some, Mike, so it's very important to pay attention. I'm going to show you what I'm going to do up here or down on the side, and then you're going to understand why I have it. If you have x ln 4 minus x ln 5, you have ln 4 minus ln 5 x's. What did I just do? I just essentially factored out the x, or if you have 4 x's and you subtract 5 x's, you have 4 minus 5 x's, right? If I have x ln 4 and I subtract x ln 5, I will have ln 4 minus ln 5 x's. Cool? Now over here, I will subtract ln 16. You might think that ln 5 minus ln 16 is ln negative. No, no. It's just ln 5 minus ln 16. But there is a log property that allows you to condense these ln's. This is ln 4/5. This is ln 5/16. You don't subtract the numbers. You use log properties to condense. And then we solve by dividing these two. I divide both sides by ln 4/5 to get rid of the ln 4/5 that's being multiplied by x. I moved it up to the power of 4.
There's no way it's on the quiz.
This is 1,000% on the quiz and on the test. This is 1,000% on the quiz and on the test. This is 1,000% an AP pre-calculus class that you guys like to say is really easy. Yes. Here. 4 to the x plus 2. 5 to the x plus 1. Here are the graphs. Here's where they intersect at some crazy number. That's 4 to the 5.213 plus 2 is equal to 5 to the 5.213 to the first. ln 5/16 divided by ln 4/5 is 5.213. Exactly what I wanted to get. This is the answer. Don't worry. Don't worry, guys. They get harder. This is the hardest question that I've seen, actually, in all my time teaching logarithms. And I'm going to show you how to do it. Ready? Here we go. No.
Wait, is it on?
No, you got to add it. Yeah, just do it on a blank page. Right? ln x plus 11 minus ln x squared plus 5x plus 6, less than 0. If you're not copying this question down, you are sitting by yourself on the other side of the room from now on. No, it's not. You're doing it right now. You two are not allowed to sit next to each other anymore. Okay? You're part of like the bro crew that needs to be. I know they're not listening right now. Okay. Step 1, I'm going to condense. Log properties used when solving log equations and exponential equations, guys. That's why we learn them. We have a rational function inside of a logarithm. I'm going to factor this rational function. Cool. Now, we know that we can only have positive values inside the logarithm. I'm going to create a number line that pays attention to the domain. What are x values that I can plug in? Well, I know negative 11, negative 3, and negative 2 are zeros in my rational function inside the logarithm. Negative 3, negative 2, and negative 11. I can do a sign analysis to figure out the sign of my rational function. This is the domain. This is like an analysis of my rational inside the log. Okay? What this is telling me is that the graph of this ln x plus 11 minus ln x squared plus 5x plus 6 only exists for these values. These are the only values where we will see graphs. Cool. But this is not the answer I'm looking for. Because I want to solve this inequality, and I haven't done anything to solve this inequality yet, because I have a logarithm, which means I need to take e to the power of both sides to get rid of the logarithm, giving me x plus 11 over x plus 3 times x plus 2. You have 2 questions like this on your homework. You will have a question like this on your quiz and on your test. I'm not joking. We wouldn't have put it on your notes if it wasn't going to be there. Nope. Keep going. They are vertical asymptotes. They are sign changes. That's fine. They are vertical asymptotes. They're sign changes. I change sign. Do you remember rational inequalities where it was like a rational function less than 1? You should have remembered that what we do in this situation is we subtract 1, we move it onto the other side, and we have an inequality less than 0. We should remember that what we do here is we use a common denominator, providing an x plus 2 and an x plus 3 to the 1, changing that 1 into x squared plus 5x plus 6. You would think. Yes, you could do that. Just be careful when you move x's around with inequalities. Okay, now we have this situation where we have our combined fraction and 1, like that. I went ahead and distributed the x plus 3 and the x plus 2 in the numerator. I'm going to subtract the x squared, subtract the 5x, subtract the 6. I get negative 4x, and I get positive 5. And then, after that, I will factor out a negative 1. I will factor this numerator. Don't worry, we're almost there, guys. No. The question on your quiz and the question on your homework is just as hard as this problem. we get this rational function that has zeros at -5, -2, -3, and 1. We will create another number line that will help solve our inequality. We have -5, -3, -2, and 1. After doing a sign analysis, we will look to see when my inequality was less than 0, as well as when it is having graphs. We will see that the answer is the combination of the intervals -11 to -5. It can't be -5 into negative infinity because I can't plug in values to the left of -11. And I don't have any values here because I don't have any values here, but 1 greater than infinity. Yes. Yo, we will have that on our quiz and on our test. I'll take the L on that question. All right, fine. Fine. Some of you appreciate challenges in this class, and some of you will step up to said challenge. We'll see who's who. All right, we'll step up to the